All right, well, welcome back, everybody. Let's continue the excitement that is trigonometry, or, well, that's what we're doing. They renamed it to pre-calculus B, but you're really studying trigonometry. So we are doing 5.4, and this is really just applications. And the first application I'm gonna start with is actually in 5.3. It's at the end of 5.3. And it has to do with like grade resistance. So if you've got like a diesel going up a road or down the road. That's my truck. Don't I make a great truck? Wait. There we go. Gotta have a little fucking choo-choo stack on it. Now it looks like a train, never mind. That doesn't look like. The grade is like a measure of this angle right here. That's the grade. And when you're driving flat, when your car's going flat this way, gravity is just pushing straight downward. And so like the force of gravity is not helping your motion at all. But when we're driving along this way, we're going uphill, the red arrow is gravity. Part of it is like pushing, I can break this up, you'll learn this if you study physics. Part of it goes like perpendicular to the incline that you're on, and part of the gravity goes this way, so it's actually holding the truck back. And same thing here, part of the force of gravity goes this way, part of the gravity goes this way, so here the gravity is speeding up the truck. And here it slows it down. That's why when you go up the grapevine, when you're going up the grapevine, there's like plenty of spots for diesels to pull over. Cause it's fighting gravity and it fucking is a lot of work for the engine, it starts to overheat. So it has to pull over and like they gotta cool off because it's just fucking hard. Gravity is a fucking bitch. It keeps us on the planet, so it is a good bitch. It keeps us alive. But yeah. And then when you're going downhill, there you will see like when you're coming down either direction on the grapevine, but more coming back into the valley. There are spots where like even when you're in your car, you can fucking stop putting your foot on the gas and your car's still fucking accelerating. Even the resistance of the road is not enough to slow down the car because gravity's pushing your ass along and diesels weigh way the fuck more than your truck or your car does. So there's like runaway ramps that you'll see them on the side of the road. There's a fucking spot for the trucks to go and it's an incline upward. So that the truck can go up it and then it starts fighting gravity so it can slow down. So it's not going hurtling down the fucking road at 150 miles an hour. And basically like killing anything in its fucking path. So great, like this is, it's an important thing, we're gonna measure that. That force that it's applying can be measured, it's F. It's the weight times sine of the theta. Now, if you want to learn more about all that stuff in physics, you can or learn more about this. It's not just trucks and cars, this applies on even like a box sitting on an incline. You can learn about it, but that's how it's working. Notice we treat this the same way that we do normal things. So maybe I should like really show that theta is like this. That's theta. Well, yeah, that's theta. This isn't theta, that's theta. I drew the wrong thing. Drew in the wrong spot. Because that's the way the force is applied. So you do sine theta off of that. So let's say we have a car that weighs. 5,500 pounds. Travels uphill. At a grade. I don't know, let's go with 6%. Calculate the forces calculate the force of gravity on the car. Give me one chance to write down. All right, 6%. I wonder. I don't want to write 6%. I wanted to write 6 degrees. That was stupid. Wrong symbol. So the force is the weight times the sine of the angle. That is 5,500 pounds. And sine of 6 degrees. And we want to make sure we are in degrees. My calculator is conveniently in radians again. I'm getting 574. This is everything my calculator is showing. We're going to say that's about 575 pounds of force. And this is called its grade resistance. Effectively makes it so like the car has to move more weight. That's what it feels like to the car. To maintain the same speed, it has to compensate for the additional force. Do we have any questions on that? Looks like the one going downhill. Let's say I don't know, let's say the car weighs 3,500 pounds. On a descent with a grade. They always do it to the whole degree, but let's change it up. Let's say 4.5 degrees. Well, here our force is our weight. Our weight hasn't changed. It doesn't do a lot of shifting here. But we want to do sine of the angle, and here we're actually rotating clockwise. This makes it so theta is actually negative. So if it doesn't say negative on the downhill, it means that you should have a negative. Now, we know from reference angles. If I have 4.5 degrees this way, and we're looking at sine, how does it relate to the reference angle here? This one just ends up getting us a negative value. And up here would be the positive value. So if you don't remember to put in a negative number in sine, you can always just attach the negative afterwards. Your force should be negative because it's gonna make it so the part feels like it's weighing less. So what do I have? 3,500 pounds times sine of negative 4.5. And I'm getting negative 274.6. Back. Write them in the right order, Jones. Pounds.
Question.
Yeah.
In this instance, then a pound is or odd number and lower number are both our results. They would be added force to the regular force of resistance in the vehicle.
Yeah.
In this direction.
Like this one adds to it, and that's why this one, since it's negative, it makes it so it's like less force to keep the car going. I know when you're coming back from like LA and you're coming in that last couple miles of the stretch on the grapevine. God damn, that shit is fun. Gets to a point where you're like, oh, but maybe I should hit the brake, cause like, I don't know. When it curves, if I'm gonna be able to fucking control this bastard. Like you start hurling down the road.
That's the fun part.
That is the, yeah, but like if there's a whole lot of other cars, you're like, but I don't wanna die. There's no fucking like safety things in it like a roller coaster would have. Alright, so next topic here, let's get, this is actually in 5.4 here. A couple things to mention on significant digits. So this, count the whole numbers that are not zero. And then we can count zeros. If. We're in the decimal. And they follow the whole numbers there. That's one time we include it. And the second time you include them is if they zeros appear between whole numbers. I'm gonna edit this one to say. or they are the only decimals. Maybe I should say zeros appear between other numbers that we have included. You'll see why I edited it to say that in a second. So we have the number 500. The only digit that matters is the 5. This is one significant digit. If I have the number 500.0, which we would probably all argue is the same value. This 5 counts, this is counts because it's after the decimal. And that means those count as well. They're in the middle. This is 4 significant digits. In general, answers can't be or should not be recorded more accurately than the digits we started with. That's why we do this. Answers should have the same number. Significant digits. A lot of people like to abbreviate that to sig figs, like significant figures. And we'll do one more example, like related to degrees. Let's say we had 39 degrees, 50 minutes, and 20 seconds. This is 5. And the reason why I didn't include these zeros here or this 0 here is this might be from rounding. And so if you want to make it clear you did round, instead of writing 500, you write 500.0. That makes it, or whatever it is, the decimal actually is. That way you're indicating it is important. I'm not, I didn't have like $495, I just rounded to 500. I actually have $500 even kind of thing. That's what the decimal shows. That concept makes sense? Just count the number of digits. Maybe I'll do one more with a big decimal, just to indicate like a little bit more. Let's say we had 0.00 35020. These are the ones that count. This is 5 digits. So we never count if the zeros are in the front. We never count them.
What's the rule that we're counting the last zeros for?
Wait, what?
Zero after the two, why is that one being counted?
Because we put it.
Okay.
Normally, if you were rounding, you don't put it. So like, if you round, that's actually an excellent question. If you rounded, you would put 0.003502. By putting the extra zero. We are indicating that was part of the exact answer. Part of the measurement, I'll say. Usually this stuff is measured. And so you can only be as accurate as the tools you're measuring with. Take some chemistry or physics courses, they'll have you do the same thing. You can only be as accurate as the tools you're using. Like if you're using a ruler that, let's say a meter stick, so that it's easy to see, like even if it goes down to millimeters, that's only 3 digits. Your answer should include 5, because you didn't measure more than 3. How could our answer have more than that? So this is gonna come up in triangle solving. So we want to have include these ideas in solving triangles. Determine, that's not what how you spell determine. Determine which angle or side has the least number sig figs, and round your answer to that many. You guys ready for some questions? So let's say we have, and we're gonna be doing right triangles here. Oh, something else I should add when I say something here. I said solving triangles, but didn't actually tell you what solving triangles means. Solving triangles means find all the sides and angles. Example. And we're gonna be working with only right triangles in our examples here. If there's a triangle, it's a right triangle. What we need to do when they are not right triangles is a lot more complicated than what we're gonna do here. So let's say we have right triangle ABC. A is 94, or not 94, A is 34 degrees. 30 minutes. C is 12.7 meters. And C is the 90-degree angle. Oh, I thought I wasn't recording for a second, I panicked. I don't know why. I don't have to record, it's a voluntary thing. In general. In general, we're gonna use C as the 90 degrees if we say an ABC triangle. So it's always a good idea to sketch a picture. That's where you should start every time. So that's my C. It doesn't matter which one I label A or B. Or the other two angles. And doesn't, if you don't know what all the angles are yet, it doesn't really matter if the angles don't have the right shape of what they really should look like. We're just trying a triangle to get the idea of what's going on. This is important. And a lot of people don't, when they're first learning it, follow it. The side opposite has the lowercase letter. That's what A, B, and C represents. So when we're using big B and little b is opposite angle B. So with that picture in mind, I'm going to redraw this triangle with actual numbers here. This is 34 degrees, 30 minutes. 30 minutes as a decimal would be 0.5. We covered converting minutes to degrees previously. That's one piece of given information we have, and the other piece of given information we have is this one right here, 12.7 meters. So if you want to write down, like make a chart of what you have and what we're looking for, you can fill it in as you're going. A is 34 degrees. I'll put the 0.5, 34.5 degrees. I've got C is 12.7 meters. And I actually have one other piece of information. What is it?
Angle C is 90.
Angle C is 90 degrees. Well, first thing, triangles have to add to 180. Any triangle, including right triangles. And in right triangles, if C is 90, then we have A plus B has to equal 90 also, so that they all end up being 180. So what does that tell us about angle B? We gotta take that 34.5, we can stick in that 34.5 degrees, right? Is that what you were going with?
Yeah.
And we do a little bit of algebra and subtract it. That 55.5. Maybe I should. $55.5. So I'll go up here and write that in up there as piece of information. Now I wanna make sure I'm following my sig fig count. This was my first calculation, am I? What is our significant digits here?
For 55.5?
Well, I mean, from the given information, how many should I use? This one is 3 and this one is 3. We don't include the zeros, so we should be going with 3 and 55.5 is 3. When you're finding the rest of the information. Try to rely only on the given information. Not any of your calculations. Why would I recommend that?
Calculations could be wrong.
Your calculations could be wrong. You could have fucked up something simple. It could have been something super simple. It could have been A was 85 degrees and you're like, I can do that in my head. 90 minus 85 is, and you fuck it up and say 15. The easier the calculation is, the more likely you're gonna fuck it up. Because you'll go to do it in your head and you'll get distracted by something or think ahead, see a number on the page, something happens. It happens all the time. And it even happens with calculators when you fucking miskey and don't check what you keyed before you hit enter. So use that. So if I wanna find, I need to still find side A and side B. This is where SOHCAHTOA comes in. My pre-existing information is angle A and side C. So I'm gonna try to use angle A, So if I wanna find side A. Let me label these, that's A, that's B. I need something that has little a is opposite. Opposite of big A. And I need something that has side C, which is the hypotenuse. So up SOHCAHTOA, opposite and hypotenuse comes with sine. So sine of A is opposite over hypotenuse. We have sine of 34.5 degrees. Equals opposite, which is the one we don't know, over C, which is 12.7 meters. So if I solve for A, I multiply, I clear the fractions. I get A equals 12.7 meters times sine of 34.5 degrees. I don't know what that is, I gotta calculate that. And I am getting 7.193359209. And this is in meters, it's a distance. Once we took the sign, it was just a value. And now this is where I kick in, I want 3 significant digits, did I write that right? Yeah, I did. I want 3 digits, so these are the 3 digits. I'll check there for rounding. Looks like I round down, A is gonna be 7.19 meters. Now, if I want side B. Side B is adjacent of A. And we're gonna use C with hypotenuse. I need adjacent and hypotenuse, that comes from cosine. Cosine of 34.5 degrees equals adjacent, which is B, over hypotenuse, which is 12.7 meters. So we clear the fractions, equals 12.7 meters times cosine of 34.5 degrees. $10.4664,026 meters. And we're drawing off three significant digits. One is the first one that counts. So I go three after it, and those are the three we have. So I'll check the one next to it, and this says round up. So B is gonna be 10.5 meters.
So in determining how many significant figures we should be solving for, are we gonna disregard the equal 90 because it doesn't fit with the other numbers?
Yeah. Well, with a right angle, we know 90, we could put 90.0000000.
Okay.
A right angle has as many digits as you need to have. Also a good question. Jordan's like my question queen. They're all been good questions. We figured the challenge until you like master it. And a lot of times we don't care about it when you're just doing like normal math. But like if it's related to something that a measurement. If we have a distance, it probably might be something we're building or something, and we wanna not get carried away. Ready for another? Okay. Does anyone need a longer? If you do, say something. Alright. One more triangle, this triangle, that last triangle had one angle one side. This triangle ABC, we're gonna have two sides. Two sides given. So we're gonna have. Little a equals 29.43 centimeters. And little c is 53.58 centimeters. Again, it doesn't matter which one we label A or B, as long as C is in the correct spot. So C equals 53.58 centimeters is the long one. The hypotenuse opposite the 90 degrees. And pick little a and little b. Just label the other angles. So I'll call that A and I'll call this B. A is 29.43 centimeters. So how many sig figs do I have? Got 4, right? They both have 4. So we're gonna use that. I'll write down what I'm gonna fill in. We know C is 90 degrees. I'll write it with 4 significant figures. Just to make ourselves happy. And C is 53.58 centimeters. So we have some options. Where do you guys want to start?
Find B, A squared plus B squared plus C squared.
You find a little B? Okay. So I heard A squared plus B squared. That sounds like we're using Pythagorean's formula, and we have 2 of those pieces of information. We have 29.43 is A. I'm gonna put centimeters there. Just to show you what happens, make sure the units are being followed. And we do not want to round until the final answer. So that's another thing. Don't follow sig figs until the final answer. No rounding midway. $29.43 squared has a lot of digits. Don't round here, use them. And that's going to be centimeters squared. 53.58 squared. Alright, so if we solve for b squared. We subtract that over. A 2004.6915 centimeters squared. That doesn't look right. Oh, yeah, 4 and 9, yeah. And then we take the square root. And the square root is normally plus or minus, and we'll look at it, we'll address that in a second. And the square root of centimeters squared, the square and the square root cancel out, we just have centimeters again. I have 2 answers here. Can we use them both? Why not? There can only be one, but why?
Negative.
Can be negative, distances can't be negative. So we're gonna go with the positive one, and so what should I put here for B? 44.77. That's 4 decimal places, or 4, not decimal places, but significant figures. Is that good for everybody? We're missing something. We're missing the units. Units matter. If you don't think they matter, talk to NASA and the International Space Agency, European Space Agency. When they both worked on a joint mission to Mars and sent a fucking satellite there, and we were using our American units and they were using their European units. And no one bothered to fucking check what the units were. And so when, after all that money was spent trying to get it there, the thing was not going fast enough to enter orbit. So when it got to Mars, it pulled it in, rather than going around it, gravity pulled it in, and the thing fucking lawn darted. And it's like millions, like 100 million or something like dollars wasted. Because they just didn't track their units. It fucking matters. It's fucking phenomenal. They're like, I don't think they made that mistake again. Generally costly mistakes, you fucking like go, oh. Learn from that shit. Alright. I need A and B. What am I gonna do to get these? Wake up, Davis.
We use SOHCAHTOA.
We're gonna use SOHCAHTOA. I like that. So if I wanna go for angle A. So angle A, what information do I have? I have little a, which is what in relation to angle A? It's the opposite, right? And C is hypotenuse. So opposite and hypotenuse is sine. I'm going for sine of A equals opposite, which is 29.43 centimeters, over hypotenuse, which is 53.58 centimeters. And the centimeters cancel. So I get sine A equals 0.549272116. How do I find A?
We use the inverse of sine.
Yeah, this is not something you're gonna do in your head. This is an inverse thing. We gotta do sine inverse. So A will be sine inverse of 0.549272116. Or if you don't like having an answer key in your function, just put the whole thing in. I can do this whole problem as one step. Sine inverse, parentheses, 29.43 divided by 53.58 end parentheses. Equals. And I get A equals 33.31709144 degrees. So what am I recording up here?
4 digit.
Which are 33.32 degrees. Now for B, we can make sure we use pre-existing information. That's a good idea. But we have an easy check when we're done. A plus B should add up to 90. So let's do angle B the longer way. That actually good for practice. Angle B, we have adjacent, right? Adjacent is A. And hypotenuse is C. This is cosine. So cosine of B equals adjacent, which is the 29.543 centimeters over the 53.58 centimeters. So we'll do the inverse again. B equals cosine inverse. And if your calculator has the answer key, this is easy to do it without the answer key. Or with the answer key. I'm gonna write down a mid step here. Showing what I would have if I wrote it. That's a 2. Well, I should have, wait, what? Oh yeah, I didn't do the inverse yet. That calculation should be the same, we already did it. Duh, already had that.
Should we, whenever we're on tests, should we go through all the steps and calculate the angle from the base, or can we subtract from 180?
You can subtract from 180, but if you're wrong, you're fucked.
Oh, yeah.
Yeah, if you're wrong on both answers. And if you calculate both and you're wrong on one, you can use it as a check. And find out if you were wrong. You know what I mean? So let's do cosine inverse of this real quick. So cosine inverse, I'm gonna use the answer key on my calculator. And it gives me 56.68290856 degrees. So up here, I'm putting 56.68. And does A plus B equal 90? I can do this as a quick check. 33.32 plus 56.68 does equal 90. So I can feel pretty good about both A and B, because I used what I had and I got something that added up. If I get something wrong here, check your work on both of them. They could both be wrong, or one could be wrong. Let's take I gotta come in break real quick. We got plenty more to do. Alright, so we got some more stuff going on here. This is kind of similar to what we were doing with grade resistance. Let's say I have a building here and it's on a cliff. And I got a flag up here on top. So this is my flagpole, and we got our little flag waving. And Justin's over here. And we'll say his head's right there as the dot. I don't want to try to put his like measures height or anything like that. We're just gonna say Justin's standing here. So he wants to look up at the flagpole. We'll say the top of the flagpole. And we'll put Jordan down here. We'll say Jordan's here. And so she's looking up at the flagpole. And let's say there is a camera at the top of the flagpole. So if we look up to something, as Jordan and Justin are doing, we call this an angle of elevation. Elevation. And the angle is your line of sight. Is between line of sight and the horizontal. And if we're like from the camera's point of view and we're looking like the camera is filming and it spots Justin is viewing, Justin's got to tip its camera down. I'm gonna draw a little horizontal line right here. These angles are called angles of depression. Not like emotional depression, but like depression in the ground kind of thing. It's a drop. Also made between line of sight and horizontal. And they both should be acute angles. Which means between 0 and 90 degrees. I'm gonna get rid of the equal sign there. If it equals, you don't have a depression or an elevation. So, procedures to solving problems like this. Step A, draw a damn picture. Some shit you can only get from the picture. B, write equations that involve one variable. Usually what you're looking for, but sometimes not what sometimes you gotta do a step before that. Let's just say I need to put a your in there. What are you looking for? And known values. Finally, solve the equation. And check to see if it makes sense.
Is the angle elevation related, so they both add up to 90.
They should be like. If you're doing it this way, they're called alternate interior angles, they should be the same value. That's from geometry. But generally, you don't have both pieces of information, I just drew the picture to illustrate two concepts in the same picture. Oddly enough, it's not in a topic in this class, they're like, nope, you probably learned geometry in high school, I don't know why. Seems like a big assumption, it's not an important assumption, you can always find the angle by doing other shit, but. So Davis's question, what I had here, if I called this theta. It said theta A and theta B. In this picture, theta A equals theta B, they're called alternate interior angles. It's not a topic that's normally taught in this class, but since it was asked. But generally, you're not gonna need to worry about it, because you're not gonna have pieces of information that. Satisfy it. But if I do Justin's angle of elevation and the angle of depression to Jordan, they're not the same. It may look the same pictorially, but like. Unless they make the same, like it's the same, then those are not alternate interiors. Alright, so. I'm gonna put up a word problem. Applications are almost always word problem. At point A. From the base of the flagpole. The angle of elevation. To the top of the flagpole. At a point A from the base of the flagpole doesn't make sense. I need to add some more information here. Let's say it's 135 feet. From the base of the flagpole. That makes a hell of a lot more sense. So 135 feet is what that says. 135 feet from the flagpole, the angle of elevation to the top of the flagpole, let's go with. 32 degrees. And 30 minutes. And our goal is find the height of the flagpole. So we got a picture. We got a flag. That's the top. And point A, we'll say is over here. We're going to assume A is on flat ground from it. I guess that wasn't stated, but we're assuming flat ground. And this distance is. This is making an angle like that. So if we're filling information from it, the base of the flagpole is right here. That's the base of the flagpole where it stands. And it's telling us the distance between point A and the base of the flagpole is 135 feet. And it's telling us the angle of elevation is 32 degrees, 30 minutes. Which is 32.5 degrees if we convert it. Some calculators do degrees and minutes. I'm sure mine does, but I don't know how to use it. And it's easier to fucking convert this to a degree than try to figure out how to use the damn thing. That's how graphing calculators are. It's easier to just fucking learn how to graph it than try to learn how to use the damn calculator. It's also more meaningful. I learned what the graph is doing. All right, and what are we trying to find?
The height of the flagpole.
All right, we're looking for this value right here, right? Let's use H for height. So SOHCAHTOA. Which one of those trig functions can we use to find H?
The sine.
So let's say, well, what do we have? we're working off angle A, right? So angle A. We need, H is opposite, right? And, oop, get that off the screen. And 135 feet looks like adjacent. And that does look to be TOA. So it looks like we're using TOA, tangent. Tangent of A is opposite over adjacent. So tan of 32.5 degrees equals H over 135 feet. So H equals 135 times tangent of 32.5 degrees in feet. That's an exact answer. This is precise. This is exact and precise. It's not a helpful answer, but it is an exact answer. Because as soon as I take the tangent of that, I'm probably gonna get a decimal that's gonna have me doing some rounding. But we're gonna do that. We're gonna do 135 times tangent of 32.5. Oh, I wonder if I that. I think so. I'm getting H is 86.00448521 feet. So what is my answer to this problem?
You still following the sig fig rules?
We should. So we're gonna wanna go with 86.0. Any questions? Are we having fun yet? So much fun. Alright, ready for more? Does anyone need this up longer? You're right here, Next problem. What? Did you need longer?
Hmm?
You need longer?
Oh, no, sorry.
From the top of a lighthouse. Karen sees a boat. That is 430 feet offshore. If the lighthouse. Or particularly where Karen is standing. Is 210 feet. Above the ocean level. What is the angle of depression to the boat? Alright, let's draw a picture. We got ground. We got a lighthouse. It's like Karen standing right there. And we got some waves. And we got boat. You don't need a complicated picture. God, how bad is your boat if that's a nicer boat? Fuck. Alright, so Karen's line of sight to the boat. Let's just go to like the tip of the boat there. We'll say we're looking at that there. So the angle of depression is that angle right there. That's what we're looking for. And we know that the boat is 430 feet away. It could be a 400 or 210-foot lighthouse, which seems unrealistic. That's why I put it on a cliff. Lighthouses are usually located on cliffs. This height here upwards would be 210 feet. Right?
How tall is 210 lighthouse?
What?
How tall would it 210 foot lighthouse be?
It would be 210 feet. 21 stories.
Oh, okay.
On average, a story is 10 feet. So what's my triangle here?
Is the theta angle the same on both sides? Is that what you were talking about?
It should be the same. But let's show that it's true. The triangle that we're actually using is this one right here. That's the right angle that we're looking at. So that means this side up here should be 430 feet. And this side here should be 210 feet. Does doing my red angle and the green angle give me the same values? Let's find out. So if I'm going off the red angle, what SOHCAHTOA should I use? It's again TOA, right? We have an opposite. Opposite is 210 feet. And adjacent is 430 feet. So we have tangent of theta equals opposite over adjacent. And if I wanted an exact answer, theta equals tangent inverse of that. This is an exact answer. I'm deliberately pointing out exact answers because on the test on the word columns, I asked you for an exact answer and then an approximate answer. Let's just make sure, like, is the green angle the same, real quick? Like theta star. Would I be using tangent?
Yeah.
And would I have the same values? Yeah, tangent of theta would be opposite over adjacent, so we can see that theta star equals theta. So you didn't have to take my word for it, we just showed mathematically that they're the same angle. Right?
Yep.
That's good shit. It's always good when I can validate something. I don't have to trust the teacher, he's shady. Well, most classes don't think that. My stats classes swear I'm gonna cheat them. Alright, so what do I get? Theta equals tangent inverse. 210 divided by 430. Make sure you're using parentheses if you do this all at once. I'm getting theta equals 26.02959219 degrees. So what is my answer here?
26 feet.
What?
I think it's, I'm sorry, 26 degrees, because I think it's 23 feet.
It's only 26 degrees, we're not gonna have a decimal, because that's true, we only have two sig figs. The 21 of the 210 and the 443 of the 430 are only significant figures, the smallest one is 2, so we only need 2 here. That equals 26 degrees. This is called an approximate answer because we rounded. As a reminder, since you're leaving, the practice exams up. It's on Canvas, look at the modules, try to take it before Wednesday, because we're gonna, I think that's when we're doing the group practice test. We'll put you together in groups and you guys will like work on it as a group and turn winners. You guys ready for more? All right. Let's go with Mark. Mark needs to know the height of a tree. From point A. The angle of elevation. Is 36.7 degrees. And then he moves 50 feet further away. And the new angle of elevation is 22.2 degrees. Find the height of the tree to the nearest foot. We got a tree. And Mark stands here. And looks to the top of the tree. And we know this is 36.7 degrees. And then he moves back 50 feet. I'll call this point B. This is 50 feet right here, we know that. And this angle is 22.2 degrees. If you have any other information, give it to us. We're gonna assume the tree's vertical, so we'll say that's a right angle. I'm willing to accept that as reasonable. That's kind of like all we got though, right? We were looking for this, right? That's what we're looking for. We're looking for H. But we don't know this distance right here. Let's call that X. So these are unknown values. So this is like having two triangles here. I can have one triangle that has 36.7 degrees and an X and an H like that. And I can have a second triangle. And this is 22.2 degrees. What about the sides on this triangle? So that's the same tree as H, and now that full distance is gonna be X plus 50, excellent. So. Godzilla is the non-religious way of saying question. Like Gesundheit, but that's religious. So Gesundheit, Godzilla is something that everybody believes in Godzilla. What can we do with this information? Well, let's call this triangle A and triangle B. What information can I get from triangle A? If I use this angle, which function am I using? This is TOA again, right?
Sine.
Sine
No.
requires hypotenuse, and I don't have that. Don't let the H trick you. H is opposite here. H is not for hypotenuse here. This is adjacent. Looks like that's the case in both of them. So I have tangent of 36.7 degrees equals H over X. And I have tangent of 22.2 degrees equals H over X plus 50. What about that?
So if in both equations, we move the X and the X plus 50 over to isolate H, then those equations would equal each other.
Excellent. So what Jordan said is to clear the fraction basically. And since these are the same H, then these two equal each other. So I have X tangent of 36.7 degrees equals. I'm gonna actually distribute here, just to save a step on my paper. X times tangent of 22.2 degrees. Plus 50 times tangent of 22.2 degrees. So now what can we do? What do we need to find with this? This will give us x, right? So like if I subtract this over. Is now tangent of 36.7 degrees. Minus tangent of 22.2 degrees. If I factor out the x, it's gonna look like that. Equals 50 tangent. 22.2 degrees. So x is gonna be 50 tangent. 22.2 degrees. Over. Tangent of 36.7 degrees minus tangent. 22.2 degrees. If I divide by the thing multiplied by x. Did I want x? Is that what we're trying to find? No, we're trying to find h. So h takes that x. And it multiplies it by that tangent of 36.7 we had. Oh, that's a clusterfuck. That is exact though. This is exact. No rounding at all. Now. Would I probably do it this way? To find it? No. I would come back here. This is how I would do it. But we should have the exact answer. To solve it, what is tangent of 36.7 minus. Minus tangent 22.2. I get 0.337284587 x. Equals 50 times tangent of 22.2. 20.404. 62204. So if I solve for x here, I'll divide. Remember, we're not rounding till the end. I probably don't need this many decimal places, since I know the end answer is gonna be in feet. I probably only need a few decimal places, but I'm gonna use it all here. So now h. Equals 60.4967528. Times tangent of 22 or 36.7 degrees. And my approximate answer. It said round to the nearest foot, h equals 45 feet. That's a lot. That's a hard problem. Who here wants to be a sailor or work on a boat? Alright, I'm gonna explain the following problems to you. We only got 10 minutes left. I'm gonna explain the following to you, so you can do like the answer the questions on like the homework. If you still need it up, just say something. You can like say leave it up,
My bad.
or hold on a second, Jones, or some shit like that. You think you could have done that without a picture? Well, okay, it was hard with the picture, right? There's, you gotta do some like, and so sometimes you gotta break the shit down. Fill in gaps like other variables of what you don't know. Every other problem we've had so far, we had all the information, we could do it as a one-step calculation. Here, we had to find X first, just so we could find H. Alright. So, for working on the homework. You'll see a couple things, when they say bearing. Like X degrees. This means X degrees off of true north. Going clockwise. So opposite of everything we've done. So on problem though, like it says bearing of 31 degrees. This means north, we generally go as upwards. We're gonna go clockwise 31 degrees. That's what that means. So like the ship's heading is going this way. Negative? No. We'll use it like generally you're gonna make a triangle out of it. It'll be like, how far away is the boat from some point up here? I'll try to make a video. Today or tonight that does like a walkthrough of these boat problems. But there is another setup it gives you. That is not the only way to express bearing. The other way is they will use like. They'll say like, north 47 degrees east. Or south. 58 degrees. East. This one means start with north. And go 47, like, so here you need to know the compass settings. North, south, east, and west. This problem is useless if you don't know compass settings. So it means start at north and go 47 degrees in the east direction. So rotate 47 degrees that way. South 58 degrees means start going south. And rotate in the east direction 58 degrees. So that's what that means. They can also do north by west. So maybe I'll say north 10 degrees west. That means it'll only rotate 10 degrees in the west direction, starting at north. And if they say south and then a west degree, let's go like 80 degrees west. It means go that way 80 degrees. So they give bearing in two different manners. If it doesn't give you a north and a south, a north, south, east, or west, it's always up true north going to the right. I'm gonna give you one more thing. I don't know if the homework has it, it's definitely not on the test. And neither are these bearing things. But one more thing. It's called the subtense bar. Surveyors do this. When you see them out on the road with little fucking stands up, this is what they're doing. So they'll have point P over here. And they're going over here and they got some triangle like this. So this entire angle is the angle theta. And they're going to some height over here that's Q. And this is like B over 2, and this is B over 2. So this distance along here, we'll call D. We can measure it from the triangle. Generally, we know theta. When you have this kind of stuff, you know theta. And you know B. So we only did like half the triangle. This is like 1/2 theta. And this is 1/2 B. And we have a right triangle. And you're looking for D. So this is an opposite and adjacent thing. So tangent of 1/2 theta equals opposite, which is 1/2 B over D, which is what we're trying to find. So if I ask you about a surveying problem, that's the setup. You'll plug in values for theta and B. I will make a video that walks through like some of this later on. Again, there's not gonna be any surveying or bearing problems on the test. All right, get the fuck out. Have a good day. Yeah.
Let's see.